Welcome, dear students. I'm Dr. Neelam Yadav from ABES Engineering College. I'm preparing this lecture video on frequently asked questions of Engineering Chemistry Unit 1. The contents which will be covered in this topic are: we'll be discussing the questions which have been asked related to the topics molecular orbital theory, molecular orbital diagram of homodiatomic molecules and heterodiatomic molecules, questions related to graphite and fullerene, related to nanomaterials, liquid crystals, and green chemistry. Now in AKTU, the question paper pattern is they are having three sections: section A, section B, and section C. In this case, section A is of 2 marks and section B and C are of 7 marks. Now, I have taken the questions from various years and odd and even semesters. And there are some of the variation in the subject code as well. So right now we are having the code BAS 102 and 202. And earlier we used to have the code KS 102T and also KS 102. Some of the syllabus was revised for present engineering chemistry syllabus. Now we are discussing here the questions. Since these questions are of 2 marks, so while writing on the paper, we have to be very precise. And if we consider question number 1, in this case, here we will not be making the molecular orbital diagram for all the 3 molecules. Here we'll be initiating with the electronic configuration. This I have discussed in my lecture video 4, unit 1. That is of ABES CETL videos. Here we can see how we will be writing the configuration of O2 molecule or O2 plus or O2 minus. And then we'll be arranging these molecules according to the increasing order of stability. This can be calculated by first calculating the bond order of these molecules. And since we are aware that bond order is directly proportional to the bond stability, so the order which is given to these molecules for their bond order, similar will be the order for bond stability as well. Now, second question is we have to discuss uh, according to the molecular orbital theory, the bond order of NO molecules. This is a heterodiatomic molecules. So here the configuration of the molecule will be different from that of O2, and the configuration which we will be following, we have to also consider by calculating the number of electrons which this molecule will be having. As we know, the nitrogen atom has 7 electrons and the oxygen atom has 8 electrons. So total this molecule will be having a number of electrons will be 15. So this will be following the configuration of number of electrons is greater than 14. In that case, what we have to do is we will be discussing about the 2p orbitals, and here the sigma molecular orbital which are formed, sigma 2px will be at lower energy level, and then pi 2py and pi 2px, these all these are bonding molecular orbital. Its energy will be higher, 2pz. So this is the sequence which will be followed for the molecule NO, where number of electron is greater than 14. And also we have to understand that this is, since it is a heterodiatomic molecule, so when we are making the diagram of heterodiatomic molecules, we have to make sure that the atomic orbital of less electronegative atom is made a level, its energy level is made lower. So this will be the atomic orbital of oxygen. This will be the atomic orbital of oxygen, and this will be the atomic orbital of nitrogen. And we will make the bonding molecular orbital lower to that of oxygen atomic orbital, and the antibonding molecular orbital at higher energy. Similarly, we will be making the CO molecular orbital diagram. This is also being this has been also discussed in lecture video 5, unit 1, ABES CETL videos. For unit 1 engineering chemistry, we can consider it from that lecture video also. You can go through that lecture video. And its bond order, as we know, that bond order is being calculated by the formula given as bond order is equal to number of bonding electrons and minus number of antibonding electrons upon 2. So bond order can be calculated with this. Also, the magnetic behavior, when the question is being asked about the magnetic behavior, in that case, we can consider the highest occupied molecular orbital. If it is unpaired, it is having unpaired electrons, then the molecule is paramagnetic. And if they are paired up, all the molecular orbitals are paired up, then in that case, the molecule is your diamagnetic. Similarly, as we have discussed question number 1, this question number 4 can also be done in the same way. In question number 1, it was asked to arrange the order of stability. In question number 4, it is asked to arrange in the order of bond length. So we are aware, and this has also been discussed in the lecture video 5 unit 1 ABES CETL videos. This is bond order is inversely proportional to the bond length. So in this case, when the sequence which is being given to the molecules on the basis of their bond order, for bond length, it will be the reverse order. Other question which is acha, okay. Now question number 5 is being asked explain why helium is monodiatomic and hydrogen is diatomic molecule. In this case, we can since helium and hydrogen are having very small molecular orbital diagram, we can also explain it by drawing the molecular orbital diagram, or we can write up the electronic configuration of both these atoms, and then we'll be calculating the bond order. For helium, the bond order will be 0, and for hydrogen, bond order is 1. So bond order, hydrogen is having a single bond, and since the bond order of helium is 0, so it can be explained on this basis that hydrogen is diatomic and helium is a monoatomic. Question number 6 is it is the arrange the following questions or ions in increasing order of bond stability. Similarly, we'll have to write down the configuration of all these molecules, and then we'll be calculating its bond order. And similarly, bond order is directly proportional to bond stability. So the sequence in which these molecules and ions are being arranged for bond order, similar will be the sequence for the bond stability as well. Now question number 7 says why O2 is paramagnetic and N2 is diamagnetic. This can be explained by writing the configuration of O2 and N2, and then we'll be finding out that highest occupied molecular orbital is fully paired up, or it is having unpaired electrons. If it is having unpaired electrons, then it will be a paramagnetic molecule, and if it is fully paired up, then it will be a diamagnetic molecule. This has also been discussed in lecture 5 unit 1 ABES CETL videos. You can go through that video. Now, next question is about arranging these molecules and ions according to the bond length. Now, similarly, this can also be, since it is a 2 marks question, this can also be done in the similar way. We can write down the configuration of all these 3 molecules and ions, and then we'll be calculating its bond order, then arranging them according to their bond order, and then we will be arranging them according to their bond length. And as we are aware that bond order and bond length are inversely proportional, so the sequence which will be given to the bond order of these molecules and ions, that sequence will be just reversed for the case of bond length sequence. Now in this topic, now we are discussing about the section B and section C questions for this topic. In this case, what we have to do, the write-up we'll be giving in our paper is like, the question is being asked, draw the molecular orbital diagram. So we have to ensure that we are drawing both the diagrams, NO molecular orbital diagram as well as N2 molecule diagram. Making of this diagram has been already discussed in lecture video 5 unit 1 ABES CETL videos. And so we will first make the molecular orbital diagram, then we'll be calculating its bond order, and then after viewing this molecular orbital diagram, we can predict the magnetic behavior of these molecules. Similar will be the case with this O2 and N2 molecules. Okay, now what we have to ensure over here is this is a homodiatomic molecule and this is a heterodiatomic molecule. So here we have to make sure that when we are making the molecular orbital diagram for homodiatomic, atomic orbitals of both the atoms are on same level or same energy level. But for the case of heterodiatomic molecules, like this is for NO and this is for O2, sorry. So in this case, the more electronegative atom will be having lower energy level as compared to other atoms. So atomic orbital of atom N will be made at a higher energy level as compared to the oxygen atom. And then similarly, as we draw or as we have heard about the postulates of molecular orbital theory, that bonding molecular orbital will be at lower energy level based on these both atoms at lower energy level, and antibonding should be above both these atomic orbitals. These postulates have been discussed in lecture video 4, unit 1 of ABES CETL videos. Similarly, question number 3 is asking about explain the paramagnetic character of O2 and diamagnetic character of N2. This can be discussed by making the diagram of O2 molecule and N2 molecule. Both are homodiatomic molecules. In that case, atomic orbitals for both will be at same energy level, and then we can check out the highest occupied molecular orbitals. If they are paired up, then that is a paramagnetic and diamagnetic, and if they are not paired up, then they will be paramagnetic. Similarly, we can draw the molecular orbital diagram and discuss the magnetic behavior and calculate the bond order of NO and N2 molecule. And this is the sequence is asked for the order of stability of these heterodiatomic molecule and ion. This can be similarly drawn as we'll be drawing the diagram of these three molecules, and then we'll be calculating its bond order, and then we'll be arranging them according to their bond order, and then we'll be arranging them according to their stability. And magnetic behavior can be found out by seeing the molecular orbital diagram, where the highest occupied molecular orbital, if it is paired up, then it is a diamagnetic molecule, and if it is unpaired, then it is a paramagnetic molecule. Now, other questions, these questions are also in lecture video 5, unit 1, ABES CETL videos. I've already discussed how we have to make this molecular orbital diagrams. Also, how we'll be calculating the bond order and then arranging them according to their bond order, or arranging them according to their stability, or arranging them according to their bond length. So these are the same. Now, question number 8 here, it is asking about the salient features of molecular orbital theory on basis of linear LCAO method. Yeah, LCAO principle means linear combination of atomic orbital, where atomic orbitals show linear combination. That is, they are also the wave functions of these atomic orbitals are being added, and also they are being subtracted. When they are being added, they form bonding molecular orbitals, and when they are subtracted, they form antibonding molecular orbitals. Now here, question number 9 is asking about explain bonding. This is bonding molecular. This is bonding molecular orbital, and this is antibonding molecular orbital. Now here, bonding molecular orbital and differentiate. And the question is differentiate between them. Bonding molecular orbital is always having energy lower than that of atomic orbitals, while antibonding molecular orbital is having higher energy as compared to the atomic orbitals. Now, bonding molecular orbital is being denoted by sigma pi, and in case of antibonding, it is denoted by sigma star or pi star. Now, bonding molecular orbitals give stability to the molecules. Antibonding molecular orbitals, they don't give stability to the molecules. This is some of the difference between the bonding molecular orbital and antibonding molecular orbitals. Now, next topic over here is about graphite and fullerene. Now, section A for graphite and fullerene. The question is why graphite is used as a lubricant. This topic has been discussed in lecture video 1, unit 1, ABES CETL video. And this question can be explained depending on the properties of graphite, where since the layers of the graphite are held by weak van der Waals forces, whenever we give pressure to that, whenever uh, it is given force, these layers slide over one another, and that is why it is being used as a lubricant. Now, section B and C will be lengthy questions, and we will have to discuss it in detail. Like question number 1 is discussing about notes on fullerenes, what are fullerenes, their preparation also. Now, when we are writing the questions, we have to give all the headings in our copies. Like um, initially, we'll explain what are fullerenes, and then we'll give a heading of preparation of fullerenes. We'll give in detail about the preparation of fullerenes. Then we'll be giving the heading of properties, and then we'll be discussing at least 4 or 5 properties of the fullerene, and then the application of fullerene. All these topics have been covered up in detail in lecture video 1, unit 1 of ABES CETL videos. Similarly, this is again the structure and application of graphite and fullerenes, and they have asked the reasons for electrical and lubricant property of the graphite. Electrical property is due to the free electron present in the structure of the graphite, which can move, and so it shows the electrical property. And lubricant property is that because the layers are attracted by weak van der Waals forces, and which can slide over each other very easily, so it is having a lubricant property. Now, this is again a repeat question, which is a question number 1. So, similarly, we have to explain in this question number 3 also. Now, question number 4 is again a repeat question, which is asking for the application of graphite and to explain about the electrical and lubricant property of the graphite. And question number 5. Okay. Now, in question number 5, it is asking the structure, preparation, properties, and application of an allotrope of carbon. So, allotrope of carbons, like diamond is an allotrope of carbon, graphite is an allotrope of carbon, fullerene is an allotrope of carbon. Here they are asking about allotrope of carbon having truncated icosahedron structure. So, this is another name for fullerene. This has also been discussed in our lecture video 1. That is a topic of graphite and fullerene. So, if they are asking for an isotope of carbon, which is in the shape of truncated icosahedron structure, so this is asking about fullerene. So, you have to write in detail about the structure, preparation, and properties and applications of fullerene. Now, next question is again a repeat question. This is also for fullerene because it is truncated icosahedron. Next is a repeat question for fullerene. Next topic is nanomaterials in our engineering chemistry syllabus. Now, in this section A is including how nanomaterials are different from bulk materials. So, bulk materials are when bulk materials are being processed, they are converted into nanomaterials. Molecular self-assembly, when they are talking about molecular self-assembly, they are talking about uh, bottom to up approach of preparation of nanomaterials. This has been discussed in our ABES CTL lecture video of lecture 6 of unit 1. So there we can see it in detail. What are nanomaterials? This nanomaterials are defined basically on the range of the diameter, the molecular size, which is in nanometers, 1 to 100 nanometer. Now, how they are different from the bulk materials? There are some of the properties, like size effect and composition effect. These are some of the properties which make it different from the bulk material and change their properties. Now, give the approach used for the preparation. What we are discussing over here for the preparation of nanomaterial is in two ways, top to bottom and then bottom to up approach. Here we will be discussing about two applications of nanotechnology, which has already been discussed in lecture video 6 of unit 1 ABES CATL videos. Now, next topic is also of nanomaterials. Here, the section we are discussing is B and C, which will be of 7 marks. Here, the questions being asked are nanomaterials, definition of nanomaterials, and then the physical and chemical properties of nanoparticles as they vary in their size. And now also we have to write down the application of nanomaterials. All these discussions can be availed from the lecture video 6, unit 1, ABACETL video. Now, carbon nanotubes are made up of graphene and graphite. If nanotubes are being made of graphene, then it is a single walled carbon nanotube. And if nanotube is made up of graphite, it is a multi-walled carbon nanotube. So this has also been discussed in our nanotech lecture 6, unit 1 lecture video. So there we can go through it. Single walled carbon nanotube. This is one of the very important topics of liquid crystal, which is mostly asked in section B and C. That is, it is a question which is being asked to write out in detail. Here, they have not given the name liquid crystal. They have used a name that is called as anisotropic liquid crystal. This is also this is the same liquid crystal which we define by a liquid crystal depending upon their properties and structure. Classified on the basis of temperature. On the basis of temperature, liquid crystals are classified as thermotropic liquid crystals. Thermotropic liquid crystals. And they are further divided into 4 categories. That is nematic liquid crystal, cholesteric liquid crystal, smectic liquid crystal, and discotic liquid crystal. This has been discussed in a lecture video 3 unit 1 of ABES CETL videos. Now next question is again of liquid crystals, and it is also asking for classification on the basis of temperature, and here it is also asking about the application of liquid crystals. Third question is also a repeat question, different types of liquid crystals. We can explain it on the basis of thermotropic liquid crystals and lyotropic liquid crystals. This is also a repeat question where they are asking for the classification of liquid crystals, and an additional question is being given over here. It is asking to distinguish between nematic and spectric liquid crystal. This has been discussed in detail in the lecture video 3 of unit 1 ABES CETL videos. Liquid crystal, again now additional questions again. Now this is also a repeat question that we have to classify the liquid crystals on the basis of temperature, that is thermotropic liquid crystals, and it's 4 types: nematic liquid crystal, smectic liquid crystal, cholesteric liquid crystal, and um, discotic liquid crystal. And also we have to explain about the application of these liquid crystals. Write a note on liquid crystal describing classification. This is again a repeat question. This is also a repeat question where they are asking for the nematic and spectric liquid crystal in detail and the applications of liquid crystals. Now, next question is, what is the concept of liquid crystals? They are an intermediate systems or phases between solid and liquid. So the properties is intermediate between solid material and liquid material. Again, it is asking for the classification on the basis of temperature, and we have to give the applications for this. One of the new topic which has been added in AKTU syllabus with the code BES, it is a green chemistry, and it is also the topic which is being generally asked in detail. So the question are, green chemistry is having 12 principles. In this question, they have asked about the 4 principles of green chemistry, and they have asked the conventional and green route method of synthesis of paracetamol. Green chemistry has been discussed in a lecture video to Unit 1 of ABES CET videos. We can go through it. There we have discussed about the 12 principles. We can pick up any 4 principles of green chemistry, and then we'll be giving the preparation of paracetamol in both conventional method and in green root method. We must ensure when we are giving the conventional method of preparation of paracetamol, we also give the points which are the drawbacks of conventional method, so that we can easily explain why green root synthesis is being emphasized. Now, in second question, they have asked the 5 principles. We can pick up any 5 principles, and we must ensure that when we are giving the principles of green chemistry, we should give examples with each principles. Again, the extension of this question is give green synthesis method of preparation of paracetamol. Here also they have asked only green synthesis method of paracetamol preparation. Now, these are the phrases where I have took these questions from. Thank you.